below. In this lecture we'll find out the value of angle theta. In the drawing we have triangle ABC. In triangle ABC, side CA equals to side CB. Therefore triangle ABC is an isosceles triangle. In addition, you know that this angle ACB equals to 20 degrees in its size. This is angle NAB that is equal to 50 degrees in size. This angle MBA equals to 60 degrees in size. Our mission is to find out the size of this angle NMB that is defined as angle theta. So first of all, I'll copy triangle ABC in a new page and we will analyze it. So actually, this is triangle ABC that I copied from the original drawing. This angle ACB equals to 20 degrees in size. And side CA is equal to side CB. Those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle ABC, theta plus theta is 2 theta, so 2 theta plus 20 degrees equals to 180 degrees. Subtract 20 degrees from the equation. And finally we get that 2 theta equals to 180 minus 20, it is 160. So 2 theta equals to 160 degrees. We divide this equation by 2 and finally we get that angle theta equals to 160 degrees over 2, it is 80 degrees. So this angle theta equals to 80 degrees in its size. This is angle theta that is also equals to 80 degrees in its size. So in the original drawing, those two angles are defined as angle theta. Each of them is equal to 80 degrees in its size. So this angle equals to 80 degrees, but we have part of angle theta, that is angle NAB, it is already equals to 50 degrees. Therefore, the missing angle must be equal to 30 degrees. Again, in order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 30 degrees in its size. Likewise, this angle theta equals to 80 degrees, but part of angle theta, that is to say angle MBA, this angle equals to 60 degrees. Therefore, the missing angle here must be equal to 20 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle here must be equal to 20 degrees in its size. In the next step, I'll copy this triangle NAB in a new page and we will analyze it. this angle NAB equals to 50 degrees in its size, and this angle theta is equal to 80 degrees in its size. Okay. Those are the two angles. So this is triangle A and B that are copied from the original drawing. We define the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. So 50 degrees plus 80 degrees plus the missing angle that is angle theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80 is 130, so 130 degrees plus theta equals to 180 degrees. We will subtract 130 degrees from this equation, and finally we found out that the missing angle theta equals to 180 minus 130, it is 50 degrees. So this angle theta equals to 50 degrees in its size, but angle theta it is actually also angle ABN. It is defined as angle A and B. Angle A and B that is equal to 50 degrees in its size, so you can write down in the original drawing that this angle A and B equals to 50 degrees in its size. We continue to focus on this triangle A and B. On this triangle A and B, those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB. You can write here that side AB equals to side NB. And here also side AB equals to side NB. In the next step, we'll focus on triangle A and B, this triangle A and B. So I copy triangle A and B in a new page and we'll analyze it. So this is triangle A and B that I copied from the original drawing. This triangle A and B, angle MAB equals to 80 degrees. And this angle MBA equals to 60 degrees. So we define the missing angle here is theta in triangle A and B. The sum of the angles must be equal to 180 degrees. So 80 degrees plus 60 degrees plus the missing angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 60 is 140, so 140 degrees plus theta. In total, it must be equal to 180 degrees. So we subtract 140 degrees from this equation, and finally we get that the missing angle theta equals to 180 minus 140, it is 40 degrees. This is the missing angle theta that is equal to 40 degrees in its size. That is to say, angle A and B equals to 40 degrees. So this is angle A and B that is equal to 40 degrees in its size. Okay. In the next step, we do a construction, that is to say, from point B, we draw line segment BD on CA in such a way that BD will be equal to BA. Okay. So, again, this line segment BD equals to AB according to our construction. So I write it down. Here, side BD equals to side AB according to our construction. So we have here two equations. from one side AB equals to NB. From the other side, AB also equals to BD, so we can write here that AB equals to BD, and from this equation NB equals to AB equals to BD, we will derive that BD equals to NB. BD equals to NB. Here, this side BD equals to side NB. In the next step, we'll focus on triangle ADB, so I'll copy triangle ADB in a new page and we will analyze it. Angle DAB equals to 80 degrees in its size, and we already found out that BD, that side, according to our construction, side DB equals to side AB. So this is triangle ADB that I copied from the original drawing. I repeat again, angle DAB equals to 80 degrees in size, and according to our construction, side DB equals to side AB. And again, we have the same rule that in front of those two equal sides, we have equal angles. That is to say, those two angles must be also equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. That is to say, angle ADB equals to 80 degrees in size, so we can write here that angle ADB, this angle ADB equals to 80 degrees in its size. So we will continue to focus on this triangle ADB. In triangle ADB, the sum of the angles must be equal to 180 degrees. We will define the missing angle as theta. That is to say, 80 degrees plus 80 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 plus theta equals to 180 degrees. We subtract 160 degrees from this equation, and finally we get that the missing angle theta equals to 180 minus 160, it is 20 degrees. This is angle theta that is equal to 20 degrees in its size. Angle theta it is also defined as angle ABD. So angle ABD equals to 20 degrees in its size. So we can write here that this angle ABD equals to 20 degrees in its size. So the small angle DBA equals to 20 degrees in its size. The big angle MBA equals to 60 degrees in its size. It is very easy to see from the drawing that the big angle MBA minus the small angle DBA equals to the missing angle MBD. Okay, the big angle MBA minus the small angle DBA equals to the missing angle MBD. So I write it down. The big angle, that is actually angle MBA, that is equal to 60 degrees in its size. Minus the small angle DBA, that is equal to 20 degrees in its size. The difference between the big angle and the small angle equals to the missing angle MBD. Repeat again. The big angle MBA that is equal to 60 degrees in size minus the small angle DBA that is equal to 20 degrees in size. must be equal to the missing angle MBD. The big angle is 60 degrees, the small angle is 20 degrees, so 60 on 20 it is 40 degrees. So the size of the missing angle MBD is 40 degrees. So this is the missing angle MBD that is equal to 40 degrees in its size. In the next step, we focus on triangle MDB. So copy triangle MDB in a new page and we will analyze it. We just right now found out that angle MBD equals to 40 degrees in its size. And we have already found out that this angle DMB equals also to 40 degrees in its size. So actually, this is triangle MDB that they copied from the original drawing. Those two angles are equal to each other. Again, according to the sum rule that in front of equal angles in the triangle there are equal sides, we get that those two sides must be equal to each other. That is to say, side DM equals to side DB. DM equals to DB. So you can write here also that side DM, this is side DM, that is equal to side DB, and also here that side DM equals to side DB. In the next step, we join points D and N together by a straight line. And we will focus on triangle DNB. Okay, again, we'll focus on the green triangle DNB. So I'll copy triangle DNB in a new page and we'll analyze it. What is the size of angle MBD? What is the size of this angle NBD? From the drawings it is very easy to see that the size of this angle NBD it is equal to 20 degrees plus 40 degrees. Okay? So angle NBD equals to 60 degrees in its size. Again, this is triangle NBD that I called from the original drawing. Angle NBD equals to 60 degrees in size. And we have already found out that DB equals to NB. Here. This side DB equals to side NB. DB equals to NB. Those two sides are equal to each other. Again, according to the sum rule that in front of equal sides in the triangle are equal angles, we get that those two angles are equal to each other. So if this angle is theta, then the other angle must be also equal to theta. In triangle NDB, the sum of the angles must be equal to 180 degrees. So here theta plus theta is 2 theta, so 2 theta plus 60 degrees must be equal to 180 degrees. We subtract 60 degrees for this equation, and finally we get that 2 theta equals to 180 minus 60 is 120, so 2 theta equals to 120 degrees. We divide this equation by 2, and finally we get that angle theta equals to 120 degrees over 2, it is 60 degrees. This angle theta equals to 60 degrees in its size, and this angle theta also equals to 60 degrees in its size. Actually, we found out that inside triangle DNB, all the angles are equal to 60 degrees in their sizes, therefore triangle DNB is an equilateral triangle. So I write it down, triangle DNB, the great triangle DNB is an equilateral triangle. And we also know that all the sides in any equilateral triangle are equal to each other, and especially it is true in the equilateral triangle DNB, that is to say, side DN equals to side NB equals to side DB. So I write it down. In the equilateral triangle DNB, side DN equals to side NB equal to side DB, write down also here in the equilateral triangle DNB, side DN equals to side NB equals to side DB. So we have here two equations. We focus on those two equations. From one side, dB equals to dm according to this equation. So we can write down that dB equals to dm. But from the other side, from this equation, we will derive that dB, again, from this equation, we derive that dB equals to dm. And from this equation, we derive that dB equals to nb. Okay, dB equals to nb. So we can write here that dB equals to nb. And from this equation, dm equals to dB equals to nb, we derive that dm equals to nb. dm equals to nb. So this side dm equals to side dm equals to, again, from this equation we derive that dm equals to db, and from this equation we will derive that db equals to dm. Okay, this letter is n, so I'm confused with this letter. It is dn actually. So from this equation we derive that dB equals to dn. Okay, so we can write here that dB equals to dn. dB equals to dn. And from this equation, dm equals to dB equals to dn, we will derive that dm equals to dn. Okay, dm equals to dn. dm equals to dn. Here, side dm equals to side dn. Those two sides are equal to each other. Okay. So, in the next step, we'll focus on this side of the straight line CA is point D. So which angles we have at this side of CA at point D? We have this angle that is equal to 80 degrees, and this angle, it is one angle out of three angles of the equilateral triangle DNB, therefore it is equal to 60 degrees, plus the missing angle NDN. So this is the straight line CA. On this side of the straight line CA at point D, we have this angle is equal to 80 degrees, this angle equals to 60 degrees, plus the missing angle here. The missing angle is actually angle MDN. Okay. 80 degrees plus 60 degrees, it is 140 degrees. Plus the missing angle, in total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 40 degrees. Again, in order to complete the sum of the angles on this side of the straight line CA to 180 degrees, the missing angle here must be equal to 40 degrees. So I write it down that we found out that the missing angle MDN equals to 40 degrees in its size. This is the missing angle MDN that is equal to 40 degrees in its size. In the next step, we focus on triangle MDN, so I copy triangle MDN in a new page and we will analyze it. We just right now found out that angle MDN equals to 40 degrees in its size. This is triangle MDN that I copied from the original drawing. Angle MDN equals to 40 degrees. And we already found out that dm equals to dn. Here, dm equals to dn. So in triangle MDN, we have those two sides are equal to each other. According to the rule that in front of equal sides in the triangle there are equal angles, we get again dm, this is dm, that is equal to dn. So those two sides are equal to each other. dm equals to dn. In front of those two equal angles, in front of those two equal sides, we have those two angles that must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta, and the sum of the angles in triangle MDN must be equal to 180 degrees. Theta plus theta is 2 theta, 2 theta plus 40 degrees must be equal to 180 degrees. We subtract 40 degrees from this equation and we get that 2 theta equals to 180 minus 40, it is 140. So 2 theta equals to 140 degrees, we divide this equation by 2. And finally we get that angle theta, the missing angle theta equals to 140 degrees over 2, it is 70 degrees. So this angle theta equals to 70 degrees in its size. Angle theta it is actually also angle DMN. So we found out that angle DMN equals to 70 degrees in its size. So here angle DMN, the big angle DMN, this is the big angle DMN, that is theta, that is equal to 70 degrees in its size. So the big angle DMN minus the small angle DMB must be equal to the missing angle, angle theta. Repeat again, the big angle DMN minus the small angle DMB must be equal to the missing angle, angle theta, that is the angle that we are looking for. So write it down, the big angle, angle DMN, that is equal to 70 degrees in its size, minus the small angle, that is actually angle DMB, that is equal to 40 degrees in size, must be equal to the missing angle, angle NMD, that is actually angle theta, that is the angle that we are looking for. Repeat again. The big angle DMN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees in size must be equal to the missing angle, angle NMB, that is actually angle theta, that is the angle that we are looking for. So 70 minus 40 is 30 degrees, so we found out that the missing angle, angle theta is equal to 30 degrees in its size, and that is the answer to the question. In the next step, I will summarize the lecture. In this lecture, we found out the size of this angle, angle theta, that is actually defined also as angle NMB. We have, it is given us the equation that triangle ABC is an isosceles triangle because side CA equals to side CB. In addition, we know that this angle ACB equals to 20 degrees in size, this angle NAB equals to 50 degrees in size, and finally this angle MBA equals to 60 degrees in size. Our mission is to find out the size of this angle theta. So first of all, I copied triangle ABC in the new page and we analyze it. So this is triangle ABC that I copied from the original domain. Side CA equals to side CB, and this angle ACB equals to 20 degrees in size. Those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle, they are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And we also have the rule that the sum of the angles in any triangle must be equal to 180 degrees, and especially it is true in triangle ABC. So in triangle ABC, theta plus theta is 2 theta plus 20 degrees must be equal to 180 degrees. We subtract 20 degrees from this equation, and we got that 2 theta equals to 180 minus 20 is 160, so 2 theta equals to 160 degrees. We divided this equation by 2, and finally we get that angle theta equals to 80 degrees in its size, so those two angles that are angle, each of them must be equal to 80 degrees in their sizes. So in the original domain, those two angles are defined as secant theta. So this angle theta equals to 80 degrees in its size, but part of angle theta, that is to say angle NAB, is already equals to 50 degrees, therefore the missing angle here must be equal to 30 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees. But part of angle theta, that is to say angle MB8, is already equals to 60 degrees, therefore the missing angle here must be equal to 80 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle here must be equal to 20 degrees. The next step, we focus on triangle A and B. So I call it triangle A and B here in the new page and analyze it. Angle NAB equals to 50 degrees, angle NBA equals to 80 degrees. So those are the two angles, and we define the missing angle as theta. Triangle A and B, the sum of the angles must be equal to 180 degrees, that is to say 50 degrees plus 80 degrees plus the missing angle theta. In total, the sum of those two angles must be equal to 180 degrees. 50 plus 80 is 130, so 130 degrees plus theta equals to 180 degrees. We subtracted 130 degrees from this equation and finally found out that the missing angle theta equals to 180 degrees from 130 degrees, it is 50 degrees. So this is angle theta equals to 50 degrees in its size. Angle theta is actually also angle A and B. So angle A and B equals to 50 degrees in its size. This is angle A and B is equal to 50 degrees in its size. We continue to focus on this triangle A and B. In triangle A and B, those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be also equal to each other. That is to say, side AB equals to side NB. AB equals to NB. So we wrote here that AB equals to NB, and also here side AB equals to side NB. Okay, in the next step we focus on triangle A and B. So I copied this triangle A and B in the new page and analyzed it. So actually this is triangle A and B that I copied from the original drawing. Angle MAB equals to 80 degrees and angle MBA equals to 60 degrees. So those are the two angles. Define this missing angle as theta. The sum of the angles in triangle A and B equals to 180 degrees. That is to say 80 degrees plus 60 degrees plus the missing angle theta. In total, the sum of those two angles must be equal to 180 degrees. 80 plus 60 is 140, so 140 degrees plus theta must be equal to 180 degrees. We subtracted 140 degrees from this equation and finally found out that the missing angle theta equals to 180 minus 140, it is 40 degrees. This angle theta equals to 40 degrees in its size. Angle theta is actually also angle A and B that is equal to 40 degrees in its size. Here, this angle A and B equals to 40 degrees in its size. In the next step, we did the construction, that is to say, from point B we draw line segment BD on CA in such a way that BD equals to AB. Okay, here BD equals to AB according to our construction. So here BD equals to AB according to our construction. So we have here two equations. From one side AB equals to NB, but from the other side AB equals to BD. So AB equals to BD. And from this equation AB equals to BD, we will derive that NB equals to BD. NB equals to BD, side BD equals to side NB. Okay. In the next step, we focus on triangle ADB. So I copy triangle ADB in the new page and we analyze it. This is triangle ADB that I copied from the original drawing. Angle DAB equals to 80 degrees in its size, and AB equals to DB according to our construction. Repeat again, angle DAB equals to 80 degrees in size, and DB equals to AB according to our construction. So those two sides are equal to each other, and the one that in front of equal sides in the triangle, there are equal angles. Those two sides that are located in front of those two equal sides, those two angles that are located in front of those two equal sides must be equal to each other. But this angle it is equal to 80 degrees, therefore the other angle must be also equal to 80 degrees in its size. That is to say, found out that angle ADB equals to 80 degrees in its size. This angle ADB equals to 80 degrees in its size. We continue to focus on triangle ADB. On triangle ADB, the sum of the angles must be equal to 180 degrees. That is to say, 80 degrees plus 80 degrees plus the missing angle theta. In total, the sum of those two angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 degrees plus theta must be equal to 180 degrees. So we subtracted 160 degrees from this equation, and finally found out that the missing angle theta equals to 180 minus 160, it is 20 degrees. This is angle theta that is equal to 80 degrees. Angle theta it is actually angle ABD that is equal to 20 degrees in its side. This is angle ABD that is equal to 20 degrees in its size. Then it is very easy to see from the drawing that the big angle MBA that is equal to 60 degrees in size minus the small angle DBA that is equal to 20 degrees in size must be equal to the missing angle DBM. Again, the big angle MBA minus the small angle DBA must be equal to the missing angle MBD. Repeat again. The big angle MBA that is equal to 60 degrees in size plus the small angle DBA that is equal to 20 degrees in size must be equal to the missing angle MBD. So 60 minus 20 is 40, so the missing angle MBD equals to 40 degrees in its size. This is the missing angle MBD that is equal to 40 degrees. Then we focused on triangle DMV. So copy triangle DMV in the new page and we analyze it. This is triangle DMV that I copied from the original drawing. We just right now found out that angle DBM equals to 40 degrees in size, and we already found out that angle DMB also equals to 40 degrees in size. This angle DMB equals to 40 degrees in size. So those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle there are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side DM equals to side DB. So you can write here also that side DM equals to DB, and the side DM equals to side DB. Okay. Those two sides are equal to each other. In the next step, we join points D and N together by a straight line. And we focus on the green triangle DNB. So copy triangle DNB in a new page. This is triangle DNB that I copied from the original drawing. The size of this angle NBD, it is equal to 60 degrees in its size. It's very easy to see. This is angle NBD. This is equal to 20 degrees plus 40 degrees, it is 60 degrees. So this angle NBD equals to 60 degrees. And we have already found out that DB equals to NB. DB equals to NB. Those two sides are equal to each other. This is DB and it is equal to NB. Okay. Those two sides are equal to each other. And according to the rule that in front of equal sides in the triangle there are equal angles, we get that those two angles must be equal to each other because they are located in front of those two equal sides. So if this angle is theta, then the other angle must be also equal to theta, and in triangle DNB, the sum of the angles must be equal to 180 degrees. That is to say, theta plus theta, that is 2 theta plus 60 degrees. In total, the sum of those three angles must be equal to 180 degrees. So 2 theta plus 60 degrees equals to 180 degrees. We subtracted 60 degrees from this equation and finally found out that 2 theta equals to 180 minus 60 is 120 degrees. So 2 theta equals to 120 degrees. We divided this equation by 2 and finally found out that the missing angle theta equals to 120 degrees over 2, it is 60 degrees. So this angle theta equals to 60 degrees and this angle theta equals to 60 degrees in its size. So actually we found out that inside triangle DNB all the angles and they are equal to 60 degrees in their sizes, therefore triangle DNB is an equilateral triangle. And we know that in any equilateral triangle all the sides are equal to each other. So in the equilateral triangle DNB, side DN equals to side NB equals to side DB. Okay, again. In the equilateral triangle DNB, side DN equals to side NB equals to side DB. You can write also that side DN equals to side NB equals to side DB. Okay, and here we focus on those two equations. For one side, dB equals to dm. So you can write here that dB equals to dm. From the other side, from this equation, we derive that dB also equals to dn. So you can write here that dB equals to dn. And from this equation, dB equals to dm equals to dB equals to dn, we derive that dm equals to dn. Okay, dm equals to dn. Here dm equals to dn, dm equals to dn. In the next step, we focused on this side of the straight line CA at point D. So which angles we have at this side of CA at point D? We have this angle that is equal to 80 degrees. Here the missing angle is one out of the three angles of the equilateral triangle DNB, therefore it must be equal to 60 degrees plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees. Those are the three angles. Those are the three angles located on this side of CA at point D. So 80 degrees plus 60 degrees is 140 degrees, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees, therefore this missing angle must be equal to 40 degrees. Okay, so we found out that angle MDN, this angle equals to 40 degrees in its size. Then I copied this triangle MDN in a new page and we analyzed it. We just right now found out, this is triangle MDN that I copied from the original domain. We just right now found out that this angle MDN equals to 40 degrees in its size. And we have already found out that dm equals to dn. Here, dm equals to dn. Those two sides are equal to each other, and therefore those two angles must be also equal to each other because they are located in front of those two equal sides. So if this angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle MDN must be equal to 180 degrees. That is to say, theta plus theta is 2 theta, so 2 theta plus 40 degrees must be equal to 180 degrees. We subtracted 40 degrees from this equation and finally found out that 2 theta equals to 180 minus 40, it is 140 degrees. So 2 theta equals to 140 degrees. We divided this equation by 2 and finally found out that this angle theta equals to 140 degrees over 2, it is 70 degrees. Angle theta equals to 70 degrees in its size. But angle theta it is actually angle DMN. So you can write down that the size of this angle DMN it is equal to 70 degrees in its size. So actually this is angle DMN. This is angle DMN. Angle DMN. This angle DMN. This angle DMN equals to 70 degrees in its size. So the big angle DMN minus the small angle DMB, this is the small angle DMN. So the big angle DMN minus the small angle DB must be equal to the missing angle theta. Okay? Again, the big angle DMN minus the small angle DB must be equal to the missing angle theta. Angle theta is also defined as angle NMB. So repeat again. The big angle DMN minus the small angle DMB must be equal to the missing angle theta, that is actually also equals to angle NMB. The big angle equals to 70 degrees, the small angle equals to 40 degrees, so 70 minus 40 it is 30 degrees. So finally found out that the missing angle NMB, that is also defined as angle theta, this missing angle NMB, that is also angle theta, is equal to 30 degrees in its size. Okay, thank you very much.